Good morning, class. We are looking at graphs of other trig functions, such as tangent, cotangent, cosecant, secant, and we delve into this concept of sinusoidal function deeper. So the objective is to look at tan, cotangent, cosecant, and secant functions. Number one, we looked at sine and cosine, and the idea is that you know the period is 2 pi. Therefore, if you cut that into 4 equal parts, it will help graph the first, second, third, and fourth arc for the sine, starting from 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0. And conceptually, the same thing here, the 4 arcs, 1, 2, 3, 4 for cosine, 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. So that's the idea of cutting it into 4 equal parts. And we notice that sine and cosine ultimately are very similar. So cosine of x minus pi over 2 has the same graph as sine. And so the period is 2 pi, the amplitude is 1 in the case of a sine omega x. This is for sine and cosine. A sine omega x or y equals a cosine omega x. The period will be 2 pi over omega, and the amplitude will be the absolute value of it. We are looking at other functions. So first, let's look at tan x from negative pi over 3 to pi over 3 to give you an idea. And just as any other function, we just plot a few pairs, and we are going to use easy numbers such as 0, pi over 3, pi over 4, pi over 6, and the same thing, the -1. For example, we know tan of 0 is 0, tan of pi over 4 is 1, so on and so forth. So we plug in for negative pi over 3 is negative square root of 3, negative pi over 4 is -1, negative pi over 6 is negative square root of 3 over 3, 0 is 0, and the rest of them are the same but positive. And here's the approximation for the sake of the x and y coordinate to be able to graph. So if we graph those very carefully, it looks something like that. Notice we're going to go from negative pi over 3 to pi over 3, just because of the restriction. Just to give you an idea, if we were to graph tan x in general, then we don't pay attention to this restriction, and sky is the limit. See, so we basically get the same answers if we use those. What if we use something like pi over 2 or negative pi over 2? Since tangent is sine over cosine, wherever cosine is 0, we get what's called undefined. In essence, we really get VA or vertical asymptotes. And cosine is 0 when it's odd multiples of pi over 2. Therefore, if we were to graph this, we get the same values for all of them for negative pi over 2 and for pi over 2. For now, we're going to put undefined, but in essence, it's a VA, the vertical asymptote, as equation x equals minus pi over 2, x equals pi over 2. So if I were to graph just one complete cycle, see what color would do the job here. So negative pi over 2, pi over 2, and this will continue indefinitely in this, and this will continue this. And now this is one complete cycle going from negative pi over 2 to pi over 2. But if we wanted to go indefinitely, on both sides. We continue, and as we can see, there are infinitely many VAs, vertical asymptotes. So VA vertical asymptotes. So let's do the cleanup. I'm going to write actually next to this. So y is sine over cosine. Domain would be all real numbers except when cosine is 0. And cosine becomes 0 when it's odd multiple. 2n plus 1 means odd multiples of pi over 2. For example, at pi over 2 or 3 pi over 2, and so on and so on. Range, there is no restriction, all real numbers. This is an odd function with the period equals pi. Remember, the period for tangent and cotangent is only pi. VA wherever cosine is 0. Cosine is 0 at this point, so this is VA short for vertical asymptote. So there are infinitely many vertical asymptotes. What about the x-intercept? Look at this function again. X-intercept when y is 0 and a fraction is 0 when the top is 0, when sine is 0, and sine is 0 when it's n pi, for example, 0, pi, 2 pi, so on and so forth. Let's look at this example. We have 2 tan x minus 1. The period is still pi because it's a tan omega x plus b. Remember, for y equals tan xt is pi. Vertical asymptote 2n plus 1 over 2 times pi. X-intercept is n pi. So for a case like this, it is pi over omega. Since it's just tan x, the period remains the same. So the vertical asymptotes remain the same. There is no phase shift. They are not moving to the right or left. And so here's the regular tan x. We're going to multiply it by 2. So we stretch it by a factor of 2. For example, this 0, 0 doesn't change, but this pi over 4, 1, 1 changes to 2, negative pi over 4, negative 1 changes to negative 2, as an example. So this is 2 tan x. Now the next one is shifting it down by 1 unit. So we're going to bring this by 1 unit. And it does have an effect on the graph such that 0, 0 goes down to 0, negative 1. Minus pi over 4, negative 2 goes down to minus pi over 4, negative 3. Pi over 4, 2 goes down to pi over 4, 1. So we are shifting it down by 1. So we start with tan x. Multiplication by 2 will multiply the y coordinate by 2 and then subtract 1 from each y coordinate. So transformation will do the job. It's important to pay attention that the period is not changing. All right. In this case, again, this is the general format. When we have omega, now we are going to divide the period pi by omega divided by 2. And what happens is, if people are looking at just basic, just show you y equals tan 2x, let's say. And if this is the case for one complete period, we would graph the same thing here. This x is pi over 4. This is negative pi over 4. So I want to make sure everybody understands what's going on. When you have, first let's go with the tangent. So this is the, I'm going to discuss the VA in a moment, but the regular tangent goes from negative pi over 2 to pi over 2. But because the period is cut in half, we're going to go from negative pi over 4 to pi over 4. That's the first thing we want to pay attention to. As far as the VA is concerned, by the way, if you look at this one, this pi, which is the period, must be changed to pi over 2. So again, replace this pi with pi over 2. Therefore, you get pi over 4. That's how we arrive at this VA. And now, again, I want you to compare this one. This is a regular tangent. One complete cycle goes from negative pi to pi over 2. Now we're going to go from negative pi over 4 to pi over 4. And that's extremely important to understand. So let's clean up. So there are two things that is going to happen. As a result of the 2, we will have a different shape. Okay, it's going to be compression along the x-axis. As a result of 3, it's going to be elongated or stretched along the y-axis. So for example, if we start with 3, this number 1 gets multiplied by 3, this one gets multiplied by 3. 0 doesn't change because 0 times 3 is still 0. And so if we multiply by 3, there's a vertical stretch. Pi over 4 comma 1 goes to pi over 4 comma 3. Negative pi over 4 negative 1 goes to negative pi over 4 negative 3. And replace the x by 2x, horizontal compression by a factor of 1/2 will result in different asymptotes. And this is the asymptotes we are referring to. So vertical asymptotes, the period has changed. Example, x equals pi over 4, x equals minus pi over 4, as I threw that for you. Now, again, we're going to go through this. We're going to go with tan x. We're going to multiply it by 3, and we're going to get x over 2. Let me make sure everybody understands. If I were to graph it just by looking at one complete cycle, this one means t equals pi divided by 1/2, which makes it 2 pi. So this concept first, which means, again, if I'm just interested in graphing y equals tan over 1/2 x, I'm going to write 1/2 x instead of x over 2 to make sure everybody is clear as to what's going on. Again, you can just look at one complete cycle looking like that. Looks almost like y equals x cubed. Now this is x equals pi, and this is x equals minus pi because of this. Now, of course, you stretch it by a factor of 3. okay? So that is because of this number. So for example, we had pi over 4, 1. Now we have pi over 2, 1, because we are stretching it along the x-axis. And now when we multiply by 3, the next one will result in this point go to pi over 2, 3. This would be for 3 tan x over 2. Okay. So again, this is one easy way. I'm going to quickly refresh your memory again. A recap is this is y equal tan x, and this is y equals tan of 1/2 x or x over 2, and then you just stretch this, becomes looking like that, pi over 2, 3. That would be the process. Let's clean up. So VA is n pi. So the reason it becomes n pi is because you replace this with 2 pi. Okay. And when you replace this with 2 pi, the 2 cancel out. You get pi times 2n plus 1, or simply n pi. Either way makes no difference. 2n plus 1 times pi is the same as n times pi in essence. So because this is doubling in size, it gets rid of the fact that this means an odd multiple of pi. So it becomes any multiple of pi. So with that being the case. So first and foremost, the regular tangent. Then we're going to use this number 3. So pi over 4, 1 becomes pi over 4, 3. And the fact that now we go with 2 pi, so look at the 2 asymptotes. This becomes negative pi. This becomes positive pi. So replace x by x over 2, horizontal stretch by a factor of 2. So, and you remember that I gave you the synopsis of that graph for you. That's how you come up with the answer. So pi over 4, 1 was to pi over 4, 3, and pi over 4 doubles up to pi over 2 because of this stretch. Remember, it's the other way around. When you have 1/2, it becomes double. That is the case. So as you can see, pi and negative pi are the vertical asymptotes. You can continue indefinitely on both sides. For example, 3 pi, and over here, we get negative 3 pi. We continue, we get 5 pi. This one. That's just I wanted to fix that. So again, I want to make sure everybody understands how this thing works. So this is 2 pi. You replace this with 2 pi, with the 2 cancel each other. Instead of pi, you put 2 pi. The two cancel each other, you get pi times 2n plus. All right, let's look at cotangent x. And cotangent x, again, loosely put, tangent looks like that, which is y equals x cubed. Cotangent looks like this, which is y equals negative x cubed. And one complete period is from 0 to pi. So this, if we were to graph this, this is x equals 0, this is x equals pi, and remember the t is still pi because it's the cotangent, right? And cotangent is cosine over sine, and we're going to discuss that in a moment. But the bottom line is, it looks almost like y equals negative x cubed, and it does have basic VAs, vertical asymptotes as such. So with that being the case, the general idea is this. Again, you go with easy numbers. Pi over 6 is square root of 3, pi over 4 is 1, pi over 3 is square root of 3 over 3, at pi over 2 is 0, 2 pi over 3. Remember, cotangent is positive in the first and the third quadrant, just like tangent, and negative in the second and fourth quadrant. So in fact, when you go from 0 to pi, you see when we look at later on inverse functions, that is the restriction we put on cotangent to cover all numbers. So with that being the case, take a look at the general idea. You have one complete cycle, and for that, it is looking like that. If you plot the pairs, x equals 0 is one vertical asymptote, x equals pi is another one, and you can write all of them. And what happens is that y equals cotangent x is cosine over sine. Therefore, cosine over sine. Domain is all real numbers except what makes sine 0. So what makes sine 0? N pi. And corresponding to that is the VA, vertical asymptotes. The period is pi. It's an odd function. And the x-intercept, this function is 0 when the top is 0. And the top cosine is 0 when it's all 2n plus 1. Odd multiples of pi over 2. Odd multiples of pi over 2. All right. Let's look at cosecant x, and y equals cosecant x is 1 over sine x. Therefore, we can graph y equals sine x and flip over the graph. So graph y equals sine x, looking like that. Here's one complete cycle. Nobody remembers that. And it continues indefinitely, right? Now, flipping over, that means goes like that. So the blue one is the graph of y equals cosecant x. Cosecant x is 1 over sine x. Therefore, the domain, everything that doesn't make the denominator 0, sine is 0 at n pi. Therefore, the domain is all real numbers except n pi, and with that goes the VA or vertical asymptotes. X equals n pi would be the vertical asymptotes. Range from negative infinity to negative 1, union 1 to infinity. So it doesn't cover the range of sine. This range of sine is negative 1 to 1. So aside from that, and the period is the same as sine, which is 2 pi. Secant, by definition, is 1 over cosine. So just graph cosine. then flip it over. So here's the cosine, and again, here's one complete cycle. And then you continue indefinitely on both sides, flip it over, and it becomes the graph of secant function, the blue one. Secant is 1 over x, therefore the domain is what makes the denominator not 0. What makes it 0? Cosine is 0 at odd multiples of pi over 2. So the domain is all real numbers except those. With that goes the VA, vertical asymptotes, or where the denominator is 0. I hope you remember the definition. One way to find the vertical asymptote was to set the denominator equal to 0 when we did that in algebra. And so 2n plus 1 times pi over 2. The range is the same as cosecant, and that means everything that sine and cosine cover aside from that. Of course, -1 and 1 are covered. And is an even function because cosine is even, so is secant. And the period is the same thing. By the way, you can see that if you, with respect to the y-axis, they are symmetric. Let's look at a couple of quick examples. So we want to graph this, and we look at the process. 2 cosecant x minus 1. We're going to graph sine x. And then we graph cosecant x. That is the process. For that, we have sine x, we flip it over, becomes cosecant x. Now that we have cosecant x, we can multiply by 2. There are 2 ways to do that. We multiply by 2, that means the vertical stretch by a factor of 2. That means if I look at, for example, this pair pi over 2, 1 now, as a result of that becomes pi over 2, 2. Every y coordinate multiplied by 2, this becomes -2, this becomes -2. That's the meaning of it. Or I can graph 2 sine x, 2 sine x, again, this is one complete cycle. Okay, I'm not going to graph the whole thing. This is y equals 2 sine x. I flip it over, and I have the graph of 2 cosecant x. So you may like this methodology better. It's your choice. And finally, we have number -1. We shift it down by 1 unit. When we shift it down by 1 unit, we have the same thing. The y coordinates change, so we shift it down. 2 minus 1 becomes 1. This becomes -3. This becomes -3. And that is the graph of 2 cosecant x minus 1. So the domain for this one goes from everything from -3 to 1 is excluded. So -infinity to -3, union 1 to infinity. The period hasn't changed. The domain hasn't changed. So as a result of this, we have a change and the difference amplitude, we have a change in the range of the function. All right, we have the following situation: two hallways of 3 feet and 4 feet, 3 feet and 4 feet wide, meet at a right angle like such. This is going this way, this is going this way. So this is the right angle, this is a right angle. Show the length of ladder. This ladder L has this formula, 3 secant theta plus 4 cosecant theta, where theta is this one. And I hope you see these two lines are parallel. If this is theta, this is theta, this is theta. Again, these two lines are parallel. Theta, theta, theta. Okay, this is 3 feet, this is 3 feet. This is 4 feet, this is 4 feet. So knowing all of the above, so let's take it from there. So we want, again, we want L, which is this distance X, and this distance Y. We want it, and again, 3 feet, 4 feet, theta. So I'm putting everything there so everybody is clear. Again, this is 3 feet, so is this one. This is 4 feet, so is this one. This angle is given as theta, so is this one, so is this one. This distance, I'm going to call it X. This distance, I'm going to call it Y. So let's look at this small triangle. X theta 3. So what is cosine theta? Adjacent 3 over hypotenuse X. And 3 over cosine theta is the same as 3 secant theta, by the way. This one is a different color. This triangle, y4 theta, you can see that sine theta is the opposite, which is 4 over y. Sine theta is the opposite, 4 over y. And if this is the case, therefore, y is 4 over sine theta. So let's put them in here. 3 over cosine theta is 3 secant theta. 4 over sine theta is 4 cosecant theta, and we are done. So we get this function. We want to graph this function, and secant, remember, is 1 over cosine. In essence, you can graph cosine, and notice the t is 2 pi divided by pi over 2, which makes it 4. So y is secant x over 1 over cosine x. We're going to graph the cosine and then the secant. So that's a general idea. But for now, let's stick with the period. 2 pi divided by pi over 2 is 4. So if you will remember, just to give you an idea, this was the graph of basic cosine function, and this was 2 pi. Now you're changing this 2 pi to 4. So you're cutting 4 into 4 pieces. So remember, the t must be cut into 4 pieces. This is 1, 2, 3, 4. So 1, 1, 1. So this is what you get, cosine of pi over 2x. And pay attention to this 4, and therefore this 4. And in fact, one complete cycle. All right, so this is cosine. The next thing is to multiply this by 3 and stretch it by a factor of 3. So, for example, 0, 1 becomes 0, 3, just as an example. And again, this is 1 complete cycle. Now we're going to flip this over. Why? Because we want to go with the negative sign. Flip this over. So the same thing, flip it over, goes like that. So flip this over, goes like that. Minus 3 cosine power 2x. And so what do you do to get the secant? You just flip this over. How do you flip this over? So first of all, wherever that there is 0, you have a vertical asymptote, okay? So it goes something like this. So you put those red ones at top of it, if you will. And it's important to see what happens. Vertical asymptotes and so forth. So remember, the domain is this. The range is this. T is 2 pi. And VA is this, is for basic secant function. Now you're going to replace the pi with 2. Why is that? Because 2 pi is the same as 4. Pi is the same as 2 in essence. We are changing the pi to 2. Again, look at this one. Pi was half of 2 pi. So half of 4, 2. That's how you arrive at that. This has gone up to 3, so this changes this from -1 to -3, and 1 becomes 3. The same thing happens with the VA, and we are done.